Hey, it's Justice here, and today we're solving Leetcode number 1, two-sum. This is arguably one of the most important Leetcode problems, and this was the first Leetcode problem that I started with. So if this is the first Leetcode problem that you're starting with too, welcome to the club. So this is also asked by a lot of top tech companies. Google, Amazon, Meta loves this question as well. It's very popular, so hopefully you enjoy my solution, my breakthrough, and walk through step by step of how we're going to solve this. So first we're going to read the problem statement. Given an array of integers, nums, and an integer target, return the indices of the two numbers such that they add up to that target. So what do they give us? They say you may assume that each input would have exactly one solution, so we're guaranteed to have a solution, and you may not use the same element twice. You can return the answer in any order, or you can return the indices in any order. So let's go through this first example. We see we have a nums array that has values 2, 7, 11, and 15, and we're trying to equal up to a target of 9. So which two indices can we use to get up to that target of 9? So just by looking at this nums array, we can see that the 2 and the 7 here, so 2 plus 7, we can see that's going to equal up to this target 9. So we just need to return the indices that we find them at. So we know that 2 starts at index 0 because in programming languages, we actually start with a 0 index. So 2 is actually at index 0, 7 is actually at index 1, and we know that 2 plus 7 equals to this target 9. So because of that, we output this 0, 1 here. We can also return 1, 0, as they said that we can return the answer in any order. Okay, let's see this example nums here. So we see we have a nums with 3, 2, and 4, and we're trying to reach up to a target 6. We can look and say, okay, we can add 3 and then add another 3, but remember, we cannot use the same element twice. So our answer cannot be two of the same elements. We can't use this 0th index 3 and then this 0th index 3 again. So that is not a solution. So what else? We can see, okay, since we can't use the same element twice, we know that 2 plus 4 equals 6. So 2 is at the first index, 4 is at the index 2. So we can return 1, 2, or we can return 2, 1, etc. Last but not least, we see that we have a nums 3, 3 here. The first 3 is at index 0, the second 3 is at index 1, and we know that we're trying to equal up to a target of 6. So we return that 0, 1. Okay, so let's see how we can go through this and kind of walk through how we're going to approach to solve this problem in code. Okay, so this is an example nums array that I've constructed that we're trying to equal up to a target of 9 to see what kind of solution we can come up with. So one thing we can do is start with 11 and check 11 with all its possible pairs. So 11, its possible pair can be 15, 2, and 7, and then we can see if any of them add up to target. If any of them add up to target, we can return those indices. If we don't find 11 with any of its pairs that equal up to target, we just go to the next number in the nums array, and then we check that number with all its possible pairs to try to find up to target. So let's run through that example. So we can start with 11. And let's see, start with 11, and we're going to check 11 with all its possible pairs. So the green is going to delineate the possible pairs, and 11's the number that we're checking all its pairs with. So let's say 11 plus 15, that is greater than our target 9, that does not equal to our target 9, so we move on here. So we say, okay, that does not equal to our target. Cool. Now we see 11 plus 2, that's also greater than our target, so that does not equal to our target. 11 plus 7, also greater than our target. So we see that 11 has no possible pairs in the nums array that equals up to our target. So now we can move this pointer here to the 15 and check 15 with all its possible pairs. So we see 15 and 2, that's greater than 9, so that doesn't equal our target. 15 plus 7, greater than 9, doesn't equal our target. And now we're going to say, okay, 15 doesn't have any possible pairings that equal up to our target, so we're going to check 2 and see all its possible pairs left and see if it equals up to target. So we see 2, 7, that does equal 9, and 9 is our target, so that's our solution. In this case, we see that 2 is at index 2. Because remember, we start at the 0th index, so this is 0, 1, this is 2, so 2 is at our second index, and then 7 is at our third index. So our actual solution here would be, our output would be 2, 3, or it can be 3, 2, either one, as I said, that we can return in any order. So you might think this is a good way to do things, and this is actually the intuitive way to think of it, but this can actually be pretty slow and the algorithm can be pretty slow overall, because this is O of n squared. The reason why it's O of n squared is because for every number in our nums array, we're potentially checking all its next possible pairs in order to find up the target. And n in this case is the number of numbers in nums. And space complexity in this case is going to be O of 1, so it's going to be constant space, so that's pretty good because we're not defining any other extra data structures. But this O of n squared is pretty slow, and if you have potentially, let's say if this nums array was even larger, because right now we're checking with the nums array which only having 4 elements, but if this nums array had 100 elements, then we would potentially be having to check 5,000 different pairs to get up to our target. So that can actually be pretty slow. So I'm going to show you a different way that we can approach this, in which we would only have to go through the nums array one time. So it would reduce this to O of n, and it would make this much quicker and a much faster pass through. Okay, so we're going to go through the most optimal approach this time, and this time we're going to be using a hash map. So how we're going to do this is initialize this hash map, and this hash map is going to be seen, and we're going to say, hey, so we have a target 9 here. We're going to start this algorithm. We start from the top, so we start at the 0th index at 11 here, and we're going to say, okay, we see that we have the number 11 here. So we're going to say, what value do we need to add to 11 to reach this target? We can find this value by doing the target minus the current number we're at. So we know that 9 minus 11 is -2. -2, let's write that here. So we say, okay, if we add -2 to 11, we're going to have a solution, because we know that 11 plus -2 equals to 9. So what are we going to do? We're going to look at our scene array. Right now, our scene hash map is empty. So we're going to say, okay, do we have a -2 in our scene hash map? No, we don't. So we don't have a possible solution just yet. So what we're going to do is say, okay, since we don't have that -2 difference in our nums array, in our scene hash map, we know that we don't have a solution. So we're just going to add 11 to our scene hash map. And we're just going to say, okay, we found 11, and 11's at index 0. And then we're going to move on. We're going to go to 15 now. Okay, so with 15, we're going to say, okay, so we have, let's erase the difference. We're going to say, okay, so what is the difference between 9 and 15? That is 6, so -6. So we know that it's going to be 9 minus 15. The difference is always going to be the target, which is 9 minus the value that we're at in our nums array. So we're at 15, 9 minus 15, that's -6. So we're going to check, okay, if we have -6 in this scene hash map for all, so if we've seen a -6 in our nums array, then we know we have a solution. So we look in our scene hash map that keeps track of the values that we've already seen, and we say, okay, we don't have a -6, so that means that we don't have a possible solution yet. So we're just going to add 15 and keep track of where we've seen it at. So we had 15 and we've seen that at the first index. Cool. And now we're going to go to 2 here. Okay, so we're going to say, okay, now we have 9. We're going to say 9. 9 is our target, and we're going to say, we always know that the difference is the target minus the current number that we're at. So the current number that we're at is 2, and we know that 9 minus 2 is going to equal 7. Okay, so we're going to look in our scene hash map, which keeps track of all the numbers that we've already seen in our nums array, and we're going to say, okay, do we see a 7 here? No, we don't. So we don't see a 7. So what do we do when we don't see the value in our scene hash map? That means that we don't have a solution yet. So we just add the 2 to our scene and we say where we've seen it at. We've seen it 2 at index 2. Okay, now we're going to move on and we're going to say, last but not least, we're at the last element in this nums array. And we're going to take the difference and see if we can find the difference or if we already seen it in our nums array. So the difference is always going to be target minus the value that we're currently at, so which is 9 minus 7. And 9 minus 7 equals 2. So we know that the difference right here is 2. So we need to see, okay, is 2 in our scene array? Yeah. Remember when we were walking through our nums array, we placed 2 and we kept track of the indices that it was at. So since 2 is actually in our scene array, we know that we have a solution. So when our algorithm finds that and we do see that, we're going to return the index that we're currently at. So the index we're currently at is 3. So the current index we're at is 3. And then we've seen that 2 was at index 2. So we're going to return 3, 2, or we can return 2, 3. Either one. And that is going to be our output. So the reason why this is a lot faster is because we only go through the nums array one time. So that's going to be O of n. So at most, we're going to go through all the numbers in our nums array. And in this example, we actually did go through all the numbers in our nums array. So at most, it's O of n, while the brute force solution that we tried before was actually O of n squared. So as this nums array increases, so let's say this nums array goes up to 100, we would only need to check at most 100 elements. While for the other example, if we use the n squared solution, if this nums array was actually length of 100 with 100 elements, we could actually have to check 5,000 different elements pairs to try to find up to this target. So this is actually saves a lot of time. But it does increase in the space complexity because we did initialize a hash map, which is the scene hash map over here. So we initialized the scene hash map in which is going to hold all the values that we've seen as we walk through or pass through this nums array. So at most, we're going to hold n elements, which is the number of elements in this nums array. So perhaps we might hold all of the elements as we're walking through our example, but this is a good trade-off. Even though we do go up in space, we do get a lot quicker in time, and your interviewers are going to actually be looking for this solution to go through. So now we're going to just walk into the code and I'll show you how to code up this solution. Okay, so let's get into the code. So first we're going to start by initializing the scene hash map that we have. And then we're going to go through the nums array. But enumerate's a function in Python that allows you to extrapolate the index and the value. So we're just going to use that to get the index and the value that we're currently at. And then we're going to get the difference. We're going to call that difference there. And the difference is the target minus the value that we're at. Okay, so we're going to say, okay, if difference in scene, that means if the difference is something that we've seen in our nums array, then we have a solution. So we're going to just return the current index that we're at, and then we're going to return the index that we've seen in our scene hash map. So that's going to be our solution. Otherwise, we're just going to update the scene hash map with the number that we're currently at, with the number and the index that we're currently at. Okay, and then we're also guaranteed to find a solution in this, so we can just input that, and that's the code. So this one is going to be, see, test case passes, this one's good. The time complexity, since we only went through the array of nums once, we might have to go through at most n elements, where n is the number of elements in the nums array, so it's going to be O of n. And then space is also going to be O of n, because we might have to store at most all the elements from our num array in our scene hash map. So all the test cases pass for those. Let's submit this. So this one is actually pretty quick. This is kind of the way they want you to go through and the solution in your interview. So make sure that you can really grasp this down. This is a great Leetcode problem to get acquainted with your skills and actually get familiar with data structures and algorithms. I'm going to be posting a lot more content on this YouTube channel on that, as we're currently prepping for Leetcode, and I just like to Leetcode as well. So stay tuned, and see you in the next video.